Okay, hi everybody. Okay, so I have explained about differentiation transformation, and then we have two methods here, which is mathematical equation, and also we can do differentiation in graphical method. So we have two methods to solve differentiation. Okay, so now we take a look in terms of the example. Okay, so for example, we have a signal xt over here. Okay, which is this our signal xt. Okay, it goes to zeros and then up here, and then go up, down, and then go to positive infinities. Okay, this is our signal, and then you need to differentiate or transform xt by differentiate it. Okay, so you need to differentiate this one. Okay, so you can choose whether you want to do mathematical method or graphical method. Since now we are given a graph, so the easiest way is to do graphical method, not equation. If you want to do equation, you need to transform this one into equation first, and then after that you can do differentiation in mathematical equation. Okay, since the equation gives us graph over here, graph of xt, so it is easier, okay, to do it in graphical method. Okay, so how to doing it? Okay, so you need to find this one, d xt. Okay, so we have dxt dt. This is what we want to find. Okay, first, okay, like previously, you need to create a section based on the graph. Okay, for example, this is the first section where start from 0. Okay, and then the graph goes up, and then it will be the second section of the graph, and then this one will be the third section of the graph, and then will be the fourth section, and then this one will be the fifth section, and then this one will be the sixth, and then this one will be the seventh, and then this one will be the eighth section. Okay, so you have X section over here for this graph. Okay, so in graphical method, you need to differentiate each section. Okay, so for the first section over here, okay, so you have 0, differentiation of 0, of course you will get 0 over here. Okay, until 0 lah, until t equal to 0, and then after that differentiation of t. Okay, so differentiation of t, dt, so you will get value of 1. Okay, understand? Okay, so we have differentiation of t. Okay, differentiation of t is equal to 1. So you have 1 over here until t equal to 1. Okay, where this one is 1. And then for the third section over here, so for the third section over here, so now you have transition, increase from 1 to 2. Okay, the increase is 1 because 2 minus 1 is 1, so it increased by 1. Okay, from 1 to 2. So that means you have for differentiation of transition, you will have impulse function over here. Okay, so you will have impulse function with the amplitude of 1 because of the increase. Okay, it increased by 1, so your amplitude is 1, so you have impulse function over there. Okay, and then after that, for the fourth section over here, so differentiation of 2, a constant 2, so you will get 0. Okay, and then done for section 4, and then for section 5. Okay, for section 5, okay, now the graph goes down, and then it's a transition, and then goes down from 2 to 1, so it means decrease by 1. Okay, so because it's decreased, so now, so differentiation of transition, okay, will give you impulse function, and then the amplitude is depend on how much it decreased. Because it decreased by 1, so you have impulse function with amplitude -1 because it decreased, so you must have negative amplitude. Okay, and then after that, for section 5, and then go to section 6. So differentiation of 2 is 0. Okay, and then for section 7, because you have decrease, you have transition and then decrease by 1, so you will have also decrease in terms of amplitude. So you have negative amplitude for section 7, which is differentiation of transition will give you impulse function. And then last one is for section 8, where you will get 0. Differentiation of 0, you will get 0. Okay, so done. Okay, for graphical mechanics, this is the graph for differentiation of our signal xt, which is dxt dt. This is the graph. Of course, you can represent this graph into the mathematical equation, where we can write this. Okay, so we have dxt dt. Okay, for this rectangular signal, so you can write it as ut minus 1. Okay, and then you have impulse function which being shift by 1, so you can add this one, delta t minus 1, and then here you have shifted by 2, so you plus, because negative amplitude, so you have negative delta t minus 2 because shifted by 2. Okay, same goes to here, because this impulse function is shifted by 3, so you have delta t minus 3. Okay, since it's negative value, so you put negative over here because it's negative value of the amplitude. So this is the final answer for our question, our example. Okay, so differentiation of dxt, we can do in graphical method, and then we will got this one. And then after that, from the graphical method, and then we can represent it into the mathematical equation, which is this one. Okay, so easy process. Okay, especially in graphical method. Hopefully you can understand. The most important thing is that for differentiation of transition, will give you impulse function, and then the amplitude of impulse function is depending how much you increase your need. Okay, alright. For example, okay, if you have here. Okay, so you have 2 minus 1 and 1, which is 2 ut plus 1 minus ut minus 1. Okay, this one. So when you differentiate this in the graphical method, so you will have, since this one the amplitude is, so the graph will be like this. So you have first section, second section, third section, and fourth section. And then you have the last one is the fifth section over here. So the first section, of course, differentiation of 0 will give you 0. And then you have transition here, increased by 2. Okay, now your impulse function, of course, okay, for section 3, and then differentiation of transition. And then go down, of course, you will get negative value of impulse function. But because it decreased by 2, so you will have negative 2 as the amplitude. And then for section 5, will become 0. Okay, here. Okay, so this is the differentiation of rectangular function. Okay, in terms of graphical method, of course we can represent this thing into the equation, which is this will give you delta t plus 1, because the amplitude is 2, so you have 2 delta t plus 1, and then minus 2 delta t minus 1. Okay, right? Hopefully you can understand this. Okay, thank you.